All right, welcome back, kiddos. The first thing we're going to talk about is a product rule when you have potentially three functions. We know what to do here when it's f times g, hopefully. It's f prime g plus fg prime. So what if we throw in a third function? It gets a little crazy. Here's how I want you to view it. We're going to pretend that we still do have two functions. We have this first function, which is f. We're going to multiply by the second function, and within the second function, there's two functions of its own. So here's what that's going to turn into. The derivative of y still kind of has this basic look to it. This is fairly standard for the product rule. It's not until you get to this fourth parenthesis that you then have to deal with the derivative of gh. And within there, it will have four of its own parentheses. You'll see this in a minute. You start with f prime times normal gh. Here you have normal f, and then times the derivative of gh, and I'll just write it like that. You still have four parentheses. I'm just sliding these over. F prime times normal gh plus f, that's this one. And then now within this one, because now we're going to look at the derivative of gh, you have four of its own within there like that. So we're just focusing our attention here. This yellow stuff we're gonna put right in here. The derivative of gh would look like this. The derivative of g times h and g times the derivative of h, like such. You can expand this if you want by distributing the f to that first thing and then multiplying the f function times that thing. So the result would look like this. You still have y prime is equal to, we'll just clean this up a little bit, f prime gh, that's this. Now if we distribute f times g prime h, it would look like this, f g prime h. And then if I took f and distributed to gh prime, it would look like f gh prime. So really what you should focus your attention to is you had three functions. We now have three expressions, and that prime kind of moved from one function to the rest. So alternatively, if I gave you four functions, let's just call them a, b, c, d, the derivative would be the derivative of a times b, c, d, a times derivative of b, c, d, then a, b, c prime, normal d, and then a, b, c, d prime. And you can expand this to a fifth function and whatnot. All right, the next thing we're going to notice is sometimes you get a combination chain rule and product rule. I'll do it this way. We'll say, what if you have a g function times a chain rule type function, f of u. You still treat it like two functions in a product. This is your first one, that's your second one. So the derivative would be the derivative of the first one times the normal second one, that's f of u. The normal first one times, and now here's where it gets a little interesting. I'll just put here the derivative of the second function, like that. I'll write it like that. You still have g prime times f of u plus g, and then here the derivative of f of u would look like f prime of u times u prime. That's how that would look. You really can't simplify this too much other than to just rewrite it like this. G prime normal f of u plus normal g, f prime of normal u, u prime. That's as complicated as you can make it. So now, I guess on worksheet 10, it's actually number 11, problem number 9. Technically, it's worksheet 11. we give you a function that is made up of a product of 3x cubed plus 1, and then a chain rule of negative 4x squared minus 3 to the power of 4. So again, applying the product rule to start, you would have 4 parentheses. That's what you would have at the start. We take the derivative of this, which is 9x squared, and then the normal negative 4x squared plus 3, minus 3 to the power of 4. Then the normal first function, 3x cubed plus 1. And then now here goes the derivative of that second function. I probably need to rewrite this, but this is where it goes. It would be 4 times the quantity negative 4x squared minus 3 to the power of 3. And then we still have to multiply by the derivative of the inside, negative 8x. That's how number 9 looks.